I welcome all of you to this discussion on ceramic powder processing or ceramic powder preparation. As you are well aware that we are now discussing module number 3 in our course on processing of non-metals. In module number 3 our focus is primarily on one of the non-metals, that is ceramics. As the course title is processing of non-metals, so our focus primarily is on the processing aspects of the non-metals, and in this particular module we have 7 different lectures that we have to discuss. In the first two discussions, if you remember, in discussion number 1 and discussion number 2, we have focused on the basic and the fundamental aspects of ceramics. We have seen what are ceramics, from where have they derived their name, the historical perspective of in context of the ceramics. We have seen that how the ceramics can be classified on the basis of the composition. If you remember, on the basis of the composition, the ceramics can be broadly classified into 4 categories, that is silicates, oxides, non-oxides and glass ceramics. And on the basis of the applications, the ceramics can be classified into a number of different subcategories like advanced performance ceramics or simple household ceramics, cement and concrete, bioceramics, and there can be a long list of ceramics on the basis of their applications. So, that we have already discussed. Then we have seen the type of bonding that is there in the ceramics. If you remember, we have seen that ionic and covalent type of bond are present in most of the ceramic materials. Then we have tried to correlate this bonding with the mechanical properties of the ceramics, and we have seen that the ceramics as compared to the metals as well as compared to the polymers have certain distinct mechanical properties which make them a different type of a material suitable for processing, because the processing techniques which are advisable or which are advocated for the use of metals and polymers sometimes may not be relevant or may not be feasible in case of ceramic materials. We have seen that the melting points of ceramics is very high, the hardness of ceramics is very high, wear resistance is good, chemical and corrosion resistance is also good, thermal conductivity in case of ceramics is poor, electrical conductivity is also poor. So, this is just a summary of the properties of ceramics, and because of these distinct properties there are special techniques which have to be used for processing of ceramics. So, this is just the summary of what we have already covered. Again I want to just revise that where this particular lecture fits in our total course, as we are discussing the course on processing of non-metals. Our focus is on different non-metallic materials, and ceramics is one important non-metallic material. So, we have divided the whole course of processing of non-metals into different modules, and now we are discussing module number 3 in which our focus is on ceramics. So, today's lecture would be focusing on the different aspects of ceramic powder preparation, because in order to formulate or in order to fabricate or in order to process a ceramic product, the powder is one of the most important raw materials which is finally blended and compacted, sometimes sintered also, in order to get the final ceramic product. So, we will see that in which particular type of application what are the processing steps for ceramic materials. But before going into that, we should first address the main point, that is what are the various types of raw materials that go into the ceramic products. And one of the important raw materials in the processing steps or the procedural methodology for making the ceramic products is the ceramic powder. So, we will see that how the ceramic powders can be prepared. If you remember, or you have just heard to that particular lecture that was on powder metallurgy, which was recorded in the phase 1, it is still available. In powder metallurgy we have seen that different types of methods are used for processing of powders. So, today also we will focus on some important aspect of powder processing, but our focus would be that how to generate or create or process or prepare the powders. But in case of powder metallurgy, if you remember, we have just focused our attention on the methods of powder preparation, and then we have shifted our attention to the powder metallurgy as a technique and seen that what are the other steps which are used for processing of products by powder metallurgy, and we have seen the mechanism of bonding that takes place and certain design guidelines which should be followed for processing of good quality parts by the technique of powder processing. So, powders are an important aspect in some of the processing techniques. Just I am giving you the reference of powder metallurgy because there also powders are used, powders are prepared, and they act as the raw material in order to transform the raw material into the final product. So, we should have a raw material which can be transformed into a final product. So, in powder metallurgy process also, powder metallurgy technique also, we have the raw materials as the powder, and these raw materials are then processed into a sequence of steps so that we can get a product. And in that module as well as in that particular course on manufacturing processes, we have seen that what type of products can be processed by powder metallurgy. But today our focus is on preparation of ceramic powders. So, with this particular introduction, why powders are being produced in order to get the final product, and which are the important powder preparation techniques, how these techniques can be classified, then what are the important features of particular technique in case of ceramic powder preparation, that we are going to see, and we will try to understand with the help of diagrams that from where the raw material comes, then what is the action taking place, and from where the output or the ceramic powder is coming out, and different mechanisms are there in operation in order to create or in order to process the ceramic powders. So, this is just an introductory discussion of what we are going to discuss today and what we have already discussed in context of ceramics. So, we have already discussed a number of things, but now actually the action is going to take place. That is, action means now we are going to process the ceramic products, though now the tangible product would be the output. But before making the product, we have to do some preparations. So, today's lecture is focusing on the preparatory aspect in which we are generating the raw material which would be later on used to process the ceramic products. So, now with this particular introduction, let us start our discussion on ceramic powder preparation. So, ceramic powder preparation, this is our main topic today. The processing of raw ceramics into ceramic products requires the preparation of ceramic powder. This point I have already highlighted in the introduction to today's lecture, that for getting a ceramic product we require the raw material. The raw material usually comes from the natural minerals. There are different types of natural minerals that exist in the environment, and then they are processed. In some cases they may require a rigorous processing so that we are going to get the desired characteristics of the powder. In many cases, depending upon the application, we may not require very sophisticated processing of the powders. So, the processing of the powders depends upon the final quality and the application for which the powder is being prepared. So, we can see in point number 1, what does this address? The processing of raw ceramics into ceramic products. So, what is the final objective of this particular module? The module is focusing on ceramics, and we have to learn various tools and techniques for making the ceramic products, because this particular module is falling under the broad umbrella of our course processing of non-metals. So, what is the broad objective or mandate of this particular course? To learn tools and techniques which can be used for processing of non-metals, and ceramics have non-metallic properties, and therefore, we should know the tools and techniques which can be used for processing of ceramic products. We see in, if you remember, in our first two discussions, ceramics 1 and ceramics 2, we have seen that floor tiles, roof tiles, glassware, cookware, bioceramics, space shuttle tiles, there are large number of applications of the ceramic. So what are those? Those are the products which have been made by ceramic as the raw material. So the processing of raw ceramics into the ceramic products. So from a raw ceramic material which can be in the powdered form or which is a mineral which is existing in our environment. So we have a raw material and it has to be converted into a tangible product. For example, we are all of us use a pen. So pens mostly these days are made up of plastic. So we have a plastic raw material which has been in a way melted or it has been molded into the particular shape in order to get the final product. So product is the pen, raw material is a plastic. Similarly, ceramic is a raw material and this ceramic product is the final objective of the whole discussion. So processing of raw ceramics into ceramic products. So if we take step by step approach, first step is there on your screen, that is the preparation of ceramic powders. In order to convert the raw material into the final product, this is an important step. What is an important step? The preparation of ceramic powders. If we compare this with the other processing techniques, for example, as an engineer, everybody has discussed or has studied the casting process. So what are the steps involved in casting process? In casting, what we are doing? We are melting the metal and then that molten metal is poured into the mold cavity and it takes the shape of the mold cavity. So why we can't do casting of ceramics? So this is an important question which all of you should be able to answer on the basis of what we have discussed in ceramics 1 and ceramics 2. Already we have held 2 discussions on this particular module or in this particular topic. Why can't we do casting of ceramics? Yes, we do, but it is slightly different, because in casting process we have to melt the raw material. The raw material is a metal and we are able to melt it because the melting point of metals is lower than the melting points of ceramics. So we can do the casting of ceramics also, but we require very good or sophisticated instrumentation for that purpose. So first and foremost we should try and learn to understand that why there are specific techniques for processing of ceramic products. Why can't the same techniques, like the techniques which have been developed, age old techniques which are being used for processing of metals or for processing of plastics, why can't those techniques be used for processing of ceramics? That is the first point which should be clear in everybody's mind, and the answer to this particular query or this particular we can say question, it lies in the discussions that we have already done, that is ceramics 1 and ceramics 2. If we just outline the properties that the ceramics possess, we will be very easily able to clearly distinguish that there are few additional we can say characteristics that the ceramics possess and therefore they cannot be processed by the conventional processing techniques. So first important point is we should try to understand, because in other cases, for example in processing of metals, we are not doing any preparation, we are directly taking the metal, melting it, or in case of machining, we are taking the raw material, we are taking a cutting tool and machining it to get the desired shape. In casting, we are melting the metal and pouring it into the desired mold cavity and we are getting the final product. But here we are doing the preparation before going to the actual processing. So what is the preparation of the raw material? The preparation of the raw material is that we are preparing the powder of the ceramic. Why we are preparing the powder? Because the other conventional techniques of processing, for example for metals and plastics, cannot be directly applied in case of ceramics. So important point I want to highlight here is that we are going one step below in the processing steps. We are manipulating or we are fabricating or we are processing our raw material, and the raw material in case of ceramics is the ceramic powder. So first point, again whatever discussion we have done till now, I want to summarize it by reading the point. The processing of raw ceramics into ceramic products requires the preparation of ceramic powders. So first and foremost requirement is that we should have ceramic powders. Second, The application and quality of the product. Now whatever ceramic product that we want to produce, for example we want to produce a cutting tool insert, or we want to produce a tile which has to be fitted into the space shuttle, or we have to produce a product which has to be put as a decorative item in our drawing room. So the applications can be different, it can be bioceramics, it can be in electronics industry. So depending upon the application and the quality of the product, we have to do the powder preparation required. So we have to define the type of powder preparation required. So we may somewhere require a very, we can say, defined or very fine preparation of the powder, so that we are able to achieve the quality for that particular application. And in many cases, as we take the mineral, we can process it slightly and bring it to that level that we can make a product out of it. So we may require lesser processing of the powder, or a huge or number of steps of processing of the powder, depending upon the quality of the final product and depending upon the application for which the ceramic powder is being processed or is being produced. So the application and quality of the product defines the type of powder preparation required. So there are number of techniques which can be used for preparation of ceramic powder, which we are going to discuss today. But first and foremost, we should try to understand that depending upon the final application, we have to decide that which process we should choose. Next step, the application spectrum of ceramics ranges from household items to space shuttles. So because the application spectrum ranges from our domestic decorative items to a sophisticated space shuttle applications, we have to focus our attention on the preparation of ceramic powders, that what type of powder would be suitable for a particular application. So that is, with this particular introduction, let us now move on to the other aspects regarding the preparation of ceramic powders. The raw materials, from where the raw materials will come, because we need to have a material which we can process into a powder. So the raw material for powder preparation are generally natural minerals. So in most cases these would be natural minerals, that is quartz, zircon or fire clay. So there is the list is endless, there can be number of types of minerals which can be used for processing into ceramic powders, but this is just to give you an example: quartz, zircon, fire clay, these are some of the examples. So the important point to understand is the raw material is available in the form of natural minerals. The raw materials need to be processed in order to convert them into the final product or the desired product with special characteristics. Now we have the raw material, we have to process it using different number of steps so that we get a final product, and the product will have certain desirable characteristics. Now the type and nature of processing may be different for different products and applications. So in previous slide, one point was there, the type and nature of the powder processing techniques is different for different types of raw material. Here the sequence of steps, if suppose if we have the powder, we require 5 different steps to get the final product. So depending upon the final product, these steps may vary. In some cases we may require a different sequence of steps, and in other case we may require a different sequence of steps. So from the ceramic powder to the final product, the number of steps required may vary depending upon the nature of the application for which the ceramic powder is being, or the ceramic product is being produced. Now coming on to another important aspect, that is the characteristics of powders. Now every raw material should possess some desirable characteristics. Now what are the important characteristics of powders that should be kept in mind? First important, the chemical composition of the powder. Let me first read all these points. Chemical composition of the powders, phase composition of the powders, then the particle size distribution, particle shape and the agglomeration of the particles. So these are some of the important characteristics. There can be other characteristics of the powders also, but these are some of the important characteristics which will define the quality of the final ceramic product. Now one by one we can see the depending upon the now final, as I have already highlighted, depending upon the final product that we are going to make using the ceramic as the raw material, all these characteristics will alter or all these characteristics will vary, or on the other hand we will say that all these characteristics will define the type of final product that we are going to produce. So if suppose the particle size is very large, we will get a definite characteristics in the final product. If the particle size distribution is very wide, one particle is of very large size, another particle is of very small size, then also this will have a bearing on the final performance of the ceramic product. So we can see, let us take an example that we have to make a high performance ceramic product. So for a high performance ceramic product, there should be certain characteristics that is there towards the end of this slide. You can see desirable characteristics depend upon the quality of product and the application for which the product has been developed. So now these are the characteristics, but desirable depending upon the final requirements of the product or depending upon the quality of the product that we are making using ceramic as the raw material, all these characteristics will vary. Now let us take an example, chemical composition. Now in chemical composition we should have a high purity chemical composition. If there are impurities, the final product that we will get may not be of very good quality. So the chemical composition should be of high purity. Second, phase composition. So in case of very high performance, we do not require many phases in the raw material. So we can choose a single phase system for high performance application. So chemical composition, I have already told that it should be having high purity. If there are impurities present, then we may not get the desirable characteristics, means if we do not have the powders of high purity, then we may not get the desired characteristics of the final product. So first important point is the chemical composition. Chemical composition should be of high purity if we want to get a good quality product. The phase should be single phase. Then particle size. Now particle size for high performance application should be fine. Fine means it should be smaller in size. So the particle size should be fine. The distribution, what do we mean by, let us try to understand the difference between the particle size and the particle size distribution. Particle size refers to the, suppose we are taking the spherical particles. So the particle size would refer to the dimensions of the spherical particle or an individual spherical particle, whereas particle size distribution will give us a distribution of the various sizes of the particles that are present in the total bulk of the ceramic powder. Suppose there are 10 different sizes that are available, that is there are particles with x size, there are particles with x plus delta x, then there are particles with x plus 2 delta x. So we have a wide range of sizes of the particles in the ceramic powder. So particle size refers to the individual particle size, and particle size distribution refers to the families of particle sizes that are present inside the ceramic powder. So we do not want very wide variety of particle size distribution, we want a narrow particle size distribution in case of advanced ceramics or high performance ceramics. So we will just revise for high performance ceramics what are the requirements. Then the particle shape should also not be very irregular. So we should focus on certain standard shape of the particle. And finally the agglomeration, we should not take agglomeration lightly, we should always focus that the agglomeration should be minimum or there should be no agglomeration of the particles when we are processing the ceramic powder. So the powder should not agglomerate, they should not form lumps, that is another desirable characteristics. So these are the characteristics of the powders of all types of ceramic powders, but desirable for certain advanced applications. Just one case we have taken, that chemical composition should be of high purity, Phase composition, we can choose a single phase system. Particle size should be fine, it should not be very large particles. Then particle size distribution should be narrow. Particle shape should be any regular shape, and the agglomeration should be minimum or no agglomeration of the particles should take place. So, the desirable characteristics depend upon the quality of the product and application. So, whatever desirable characteristics I have told, those are related to the advanced applications of ceramics or high performance ceramics or high performance ceramic products. But if we want to make a suppose pottery item, or we want to make a tableware for as a decorative item, in those cases we may not be that much stringent with the characteristics of the powder, as I have already discussed. We may be little bit liberal in the choice of particle size or in the choice of particle size distribution. We may also be liberal with the particle shape. So, depending upon the application, if it is a decorative item, we may not be very stringent in our choice of the characteristics of powders. But if we are choosing a very high and sophisticated advanced application of a ceramic product, in those cases our focus would be on certain desirable characteristics. Now, these are important, we should remember these characteristics. Now, coming on to the next point, that is, we have seen till now that why do we need to process the ceramic powders. I think given adequate discussion about the importance of preparation of ceramic powders, because the tools and techniques that are used for processing of ceramic products is quite different from the processing of metals and polymers, and therefore, the raw material in case of ceramics is the ceramic powder. So, that is one important point. And then we have seen, when we are able to fabricate or process the ceramic powder, what are the essential characteristics that should be taken into account, that is the chemical composition, the particle size distribution, particle shape and agglomeration. These are some of the points that have to be taken into account. Now, these particular characteristics are variable. So, they vary depending upon the quality and the application for which the powder is being processed. So, we have taken two cases, at least one we have discussed in detail, that if it is a advanced ceramic or it is being used for high performance, then we can choose certain desirable characteristics, which has already been discussed. Now, our focus would shift in today's discussion on the preparation of the ceramic powders. So, on your screen you can see the ceramic powder processing can broadly be divided into two categories: chemical processing of powders using the chemical reactions or the products of the chemical reactions which are in the form of fine powders, and the mechanical preparation methods in which the direct contact of the particles with some agents would result into, the agents would be some metallic balls or something that we will see in the subsequent diagrams. In case of mechanical, we are doing grinding and milling, and ball mill is an important apparatus which most of the engineers might have heard of. So, today we will see a simple diagram of the ball mill also. So, ceramic powder processing can broadly be divided into two categories, that is mechanical and chemical, and today our focus would primarily be on the mechanical aspects in which the raw material is coming and then some forces are acting on that raw material so that it is being converted into a powder form. So, these are some of the techniques as which are highlighted on this particular slide, that is milling, crushing or grinding. So, these techniques are used for getting the ceramic powders. So, it involves crushing, milling in a ball mill or grinding ceramic raw materials into the small particles. So, we can do the milling, we can do the grinding, or we can do the crushing of the particles to get the desired powders. So, these are some of the techniques which are used for producing the ceramic powder. Many of these we will try to understand with the help of diagrams. Now, first and foremost, let us see a very important device or instrument or machine which is used for making the ceramic powders, that is called a ball mill. A ball mill is a machine with a rotating hollow cylinder partly filled with steel or white cast iron balls. So you can see there are broadly now till now two components here, that is, one is a horizontal cylinder or a hollow cylinder, second are the steel or the white cast iron balls. So there are balls, hard balls and a cylinder. So these are the two important points to note. Then depending upon the powder amount, the powder properties, different types of mills are used for dry and wet grinding. So depending upon what type of final product we want, a product of these particular operations, that is milling operation or crushing or grinding operation in case of ceramic powder preparations, is the ceramic powder. So the raw material is a kind of a mineral or any naturally occurring mineral or any synthetically made mineral, but the output is a ceramic powder. So that is the basic, we can say, step by step procedure for getting a ceramic powder, that there is a process can be milling, crushing or grinding, the raw material is being fed into the process and the process gives you the ceramic powder. So now depending upon the powder amount, the powder properties, we want that what should be the quantity of the powder that we should be able to produce on an hourly basis or a weekly basis, and what properties the powder should possess. Based on that, there can be different types of machines or equipment that can be used for processing of raw materials into the ceramic powders. Now let us one by one we can see that what are the various processes. First one is ball milling. So let us try to understand the basic principles of ball milling. So ball mill grinds the material by rotating a cylinder. So basically the words are being used interchangeably. So the operations are milling, grinding and crushing. So the objective finally is to produce a ceramic powder. So ball mill grinds the material by rotating a cylinder. As we have seen in case of a ball mill, which is a machine, there is a cylinder and there are hard balls inside the cylinder. So it grinds the material. So raw material is put inside the ball mill, and how it operates? It operates by rotating the cylinder. The cylinder continuously rotates with the hard balls, causing them to fall back into the cylinder and onto the material to be ground. So basically the impact between the two balls or two hard balls, in between we may be having a ceramic particle or a ceramic raw material which would be broken down or shattered into a ceramic powder. So ball mill grinds the material by rotating cylinder. There is a cylinder which is continuously rotating. Inside it is having the hard balls. The balls strike against each other and the strike against the wall. In between there can be ceramic raw material. We will try to understand with the help of a diagram also. So the ceramic would be processed into the ceramic powder. So the raw ceramic would be converted into the ceramic powder with the help of ball milling. So the impact of the balls is important in reduction of size of the ceramic particles. So as I have already discussed, that the balls would be hitting against each other, balls would be hitting against the walls of the cylinder, as well as the balls would be hitting against the ceramic raw material, with the overall objective of reducing the size of the particles. So basically we would be getting the ceramic powder after the ball milling operation. So the impact of the balls is very important, and it is mostly used for brittle materials. So as we all know that ceramics are brittle in nature, therefore the ball milling operation is quite suitable for ceramic materials. Now another important point in context of the ball milling operation is that the diameter of the mill decides the speed of the mill. So if we have a huge diameter of the ball mill and it has to be rotated, we will rotate it at a slower speed. But if we have a smaller diameter ball mill, we can rotate it at a faster speed. So the diameter of the ball mill or the cylinder decides the speed of the mill. Generally the rotational speed is less than 20 rpm. It may vary within a particular range, but usually it is less than 20 rpm. As we are discussing the working principle of ball milling, there are a few things that we have to keep in mind that we are discussing one by one. So, you can see point number 2, that the diameter of the cylinder should be inversely proportional to the rotational speed. The larger the speed or the larger the diameter, the slower should be the speed, or the smaller the diameter of the cylinder, we can go for larger speeds. Now, why we should take care of this precaution? You can see in point number 3, if the speed is too high, that is the rotational speed of the cylinder which is carrying the balls and the ceramic powder, if the rotational speed of that cylinder is very large, then what is going to happen? So, it becomes to act like a centrifuge, and the balls being heavier and dense goes towards the boundary or the periphery of the cylinder, and we want an impact of the balls among themselves and with the wall of the cylinder, as well as they should hit the ceramic powder, so that the ceramic powder gets shattered and we get a fine ceramic powder, or they should crush the ceramic raw material into the ceramic powder. So, the speed is, if the speed is too high, then the balls would go towards the periphery and the effective collisions between the ball and the ceramic raw material would not be there. So, now we will try to quickly go through a number of diagrams and try to understand that how the ceramic powder is crushed by various mechanisms to get the ceramic powders. On your screen you can see the simplest diagram of ball milling. In this diagram, these black spheres represent the balls. The material of the balls can be some very hard steel, or it can even be a harder material than steel. So, basically we have hard balls, and this green portion is representing the ceramic. So, this rotates continuously, and because of the collisions or the impact of the balls against the ceramic raw material, we get the ceramic powder. So, this is just showing one particular position inside the ball mill. So, here we can see these bigger balls represent the hard balls which are acting as an heating medium, and the other green portion shows the ceramic powder. So, here we can see there are bigger lumps of ceramic raw material which have been broken down into the smaller ceramic powder particles. So, basically in ball mill, this cylinder rotates continuously and the speed is not very high, it is to the tune of suppose 40 RPM, sorry, less than 20 RPM, and the balls are hitting the ceramic raw material to generate the ceramic powders. So, this is one of the simplest process of making ceramic powders, that is the process of ball milling. Now, we will see some other processes. I will draw a few diagrams, simple diagrams to just explain that how the ceramic raw material or the mineral is crushed to make the ceramic powder. So, on your screen you can see I am going to draw a simple diagram of a roll crusher, that how a roll crusher crushes the raw material. So, this is one roll, and then we have inside another roll, it is rotating, then we have another roll, so on your screen you can see we have two rolls, and in between we put the lumps of ceramic raw material, and when it is pressed inside the two rolls, rotating rolls, we get very fine ceramic powder particles. So, this is a simple process, it is called roll crusher, or we can say roll crushing. So, it is a simple, there are two rotating rolls, in between we are putting the bigger lumps of ceramic raw material, and what we are getting? We are getting the smaller or very fine size ceramic particles. Now, the size of the particle that we are getting will depend upon the process that we have chosen. So, this is one of the processes for producing the ceramic powders, and we can see the diagram of this particular process also. Let us see. This is, we can see a schematic diagram of the roll crushing. So, in this particular diagram you can see that this is the ceramic raw material hopper through which the bigger particles are coming, they are getting crushed inside the two rotating rollers, and finally we are getting the completed powder or the crushed powder or very fine powder. So, there are these two rollers, and this is the adjustable roller. It is written clearly adjustable roll. So, this is the adjustable roll and this is the fixed roll. Now, depending upon the size that we want to produce and depending upon the size of the raw material that is coming from the hopper, we can adjust the center of this particular adjustable roll to get the particular size of the final ceramic powder. So, we can control the distance, center to center distance between the two rollers or the two rolls in order to get the desired size of the final ceramic powder. So, this is one process which we have seen, that is roll crushing. Prior to this we have seen ball milling. Now, let us see another process. I will just draw a very simple diagram for you for that process. So, let us see another process on your screen. I am going to draw another diagram in which you can see this is we can say the schematic representation of the hammer milling process. So, on your screen you can see, now this is actually the hammer. Which is we can say rotating. So, we have a hammer and the raw material we can see is coming in a bigger lump form, and here it is being hammered down into very fine size ceramic particles. So, the hammer inside the chamber is rotating and it is crushing we can say the larger size ceramic lumps into very fine ceramic powder. So, now let us see the diagram of hammer milling. On your screen you can see a schematic representation of the hammer milling process. In this you can see this is the grain hopper from where the raw material is coming, this is the delivery device through which the raw material is coming, and there in the previous diagram that I have drawn there were only two hammers, but here we can see there are 1, 2, 3 and 4 independent hammers. So, this is the rotor through which we will rotate the complete assembly. Here we can see the rotation is shown, this is the next position, and for this one this is the next position. So, this is rotating and the raw material is entering from this, and the raw material would be hammered down and we will get the take away smaller size ceramic particles. So, in this particular we can see this is the grinding screen through which the particles would be coming down, and these are the hammers. This is 1, 2, 3 and 4, and this is a rotor shaft to give the rotation, and this is the rotor. So, basically in this we are hammering down or we are shattering down the ceramic product or ceramic raw material into the final product that in this particular process is the ceramic powder. So, we are having a ceramic raw material, we are putting it through the delivery device into the main chamber where the hammers are operating on the ceramic raw material and converting that into very fine ceramic powder. So, this is another process which is used for making the ceramic powders and it is called the hammer milling. So, till now we have seen three processes, which are, first one was the ball milling, the next one was the roll crushing or the roll crusher, in which two rolls were operating and they were crushing the raw material into the fine ceramic powder, and now we have seen the third process, which is the hammer milling operation, in which the hammers are crushing or milling the material into the desired shape or the desired size. Next we will see one or two more processes which are used for processing the ceramic powders. So, on your screen you can see one more diagram I am going to draw, that is we can call it as a gyratory crusher. So, this is a simple representation of a gyratory crusher. Now, this is the main acting member which gyrates and here this is the, we can say, main area where the action is actually taking place. So, we can see the raw material is crushed here into smaller size particle. So, this is a, whatever I am highlighting here, this is a solid section and it crushes the material by the gyratory motion. So, the bigger size particles are put as an input and because of the gyratory action, the bigger size particle or the bigger size ceramic parts which are put into the system are crushed into the smaller size ceramic particles, and this particular type of system is called the, as I am writing on your screen, you can see this is called the gyratory crusher. So, we have another mechanism which is called the gyratory crusher. So, the word gyratory is coming from the movement of the, we can say, main crushing member. It gyrates to remove or to bring down the size of the ceramic powders. So, basically we have seen till now 4 processes in which the use of these processes will help us to get the ceramic powders. Now, what are these 4 processes? First one was the ball milling, then we have seen the roll crusher, then we have seen the hammer milling, and now we have seen the gyratory crusher. So, the last process that we want to discuss today is on your screen. You can see I am going to draw another diagram in which we will see that how a jaw crusher works. In a jaw crusher, quickly I will draw the diagram. This is the ceramic that we want to reduce into smaller size, and where are the jaws? Now, this is the jaw, and it is fixed here. And this particular jaw will move and will crush these ceramic lumps into very fine size ceramic particles. So, basically the movement is like a jaw as we chew the food that we eat. So, in similar manner the 2 parts of the jaw would hit, or 2 parts of the system would hit the particles and the size of the particles would get reduced, and this type of the crushing mechanism is called the JAW, jaw crusher. So, this is the jaw crusher in which the bigger size ceramic lumps are broken down into smaller size ceramic particles. So, the size of the particle can be controlled. So, we can see that what is the final size that is desired, and accordingly we have seen there are number of processes which can be used for producing the ceramic powders in a mechanical manner. There are other techniques also for producing the ceramic powders that we would be discussing, but these whatever we have discussed today, these are the mechanical techniques for producing the ceramic powders. And here we can see that there are number of techniques starting from ball milling, roll crushing, then we have seen the gyratory type of a motion which is used for producing the ceramic powders, and finally the jaw crusher on your screen. So, different techniques can be used. Now, the final size, the distribution of the size are some of the important decisions that have to be taken. Now, some of the process may give a very wide distribution, some of the processes may give a very wide distribution of the sizes, that few particles are of very big size and the other particles are of very small size. So, we do not want a very wide distribution, then we will not go for that particular process. We will go for only that process which would give a very fine size, or which will give a very narrow range of the particle size distribution. Similarly, if we want very fine, very small size particles, we will choose the process appropriately. In many cases, because of the process mechanism, there may be wear of the parts which are used. For example, in ball milling, if the balls are not very strong or very hard, strong is not the correct word in case of wear, we should say hard. If they are not very hard, then the wear of the balls even may take place, and the wear debris may, we can say, form into the ceramic powder, or maybe react with the ceramic powder. In many cases may get mixed with the ceramic powder, and we will not get a very good chemical composition of the ceramic powder. So, we have to be very choosy in the selection of the process. There are number of processes which can be used for producing ceramic powder, but we have to choose the process as per the requirements of the final product, because according to that only we want the ceramic powder. In the very beginning of today's lecture, we have seen that what are the powder characteristics and what are the desirable powder characteristics for advanced ceramic products. So, with this we come to the end of today's discussion, in which we have seen that why do we need to produce the ceramic powders, how in powder metallurgy what is the importance of the powders, and then what is the importance of the powders in ceramic product development. Then we have seen that what are the desirable powder characteristics for advanced ceramic products. Specifically, we have seen few important powder characteristics like the particle size distribution, chemical composition, and the agglomeration. So, there are few characteristics that we have discussed, and finally, we have seen that how the ceramic powder processing techniques can be classified. They can be classified into two, that is, point number one is mechanical and next is the chemical processes. We have today discussed the mechanical processing methods for processing of ceramic powders, in which we have seen number of processes like ball milling, roll crushing, gyratory method of making powders, and the jaw crushing. So, with this we come to the end of today's discussion, and in the next discussion we will discuss other important processing aspects of ceramics. Thank you.